all been waiting for. All the schools are set and ready to show us what they've got. Remember, it's been 3 days of exciting exchange of ideas and building of the latest innovation, centering around recycling. So I'll be handing over the mic to the lead judge to take us from one stall to another so we see what innovative ideas some of these schools have got to offer. Follow me as we go through this journey together. Thank you very much.
Thank you once again. So we are going to be going around the room. Let me introduce the consultants on the program, and then I'll also introduce some of our guest judges as well. So I have myself, Dr. Lucie Japong, lead consultant on this project. I have Mr. Nehemiah Atiga, who is also one of the consultants on this project, and Mr. Michael Mensah as well. But today, because it's such a special event, we have some guest judges, both from industry, from all over, to come and add their voice and for them to see what the students have been up to over the last 2 days, 2 to 3 days. So I'd like to invite or introduce Ms. Sheila Achia, who's Engineer Sheila Achia, I must say, who's one of our guest judges today. We have Ms. Frida Yorson. Give her a round of applause, please. We have our non-scoring judge, primetime manager, MD, Nanekia, and then we have Mr. Frank Jackson Udru. We have Mr. Jackson Udru from Absa Bank, one of our sponsors of this program. So what we're going to be doing is that we're going to be going around each school. Each school now has 10 minutes to present to us what the idea is, what they've done, and to showcase it to us as well. We'll then take 2 questions from our guest judges, and then we'll move on to the best school. Whilst we're going around, can you please stay at your stands? Please keep it low if we are not at your stand yet, so that we'll come and see what amazing projects you have. We'll start off with St. Augustine's College. But before we start off with St. Augustine's College, I just have to mention that, bear in mind, everything that you've seen here was built over a 9-hour period. All the students started with raw materials, and whatever they're able to demonstrate today is something they've built over the 9-hour period to demonstrate and showcase to all of us. So we'll start off with St. Augustine's College. Give him a round of applause, please.
Thank you for the opportunity. Allow me to give a quick preamble on what inspired our innovation here. We all know what waste is. We know that management of waste is one of the pressing problems of our current world. We know segregation of waste. My name is Mauli Ashinyo. This is.
I'm Anon McKay.
And I'm Dennis Derry.
Okay. Waste. Separation of waste. We did a little research back in our school. We put bins, right, and labeled them plastic. This is for metals. This is for wood, or in the paper and the rest. We realized that people really didn't take time to read or understand what they are supposed to do there and place them in their respective bins. So our focus here was to think. We were pondering the question: what happens to that unsorted waste at the dam site or wherever they are taken to? What happens to them? How do we separate them before we recycle them? That's what our project here basically does. It's going to separate some waste and then
materials is to sort them and process the plastics into renewable products such as plastic spoons, plastic bowls, and the soles of shoes. Let me hand it over to my brother Dennis Derry to explain how our system works.
Okay, thank you very much. I guess you're as excited as I am to take you through this plastic waste recycling system journey. Okay, so to begin with, we have 2 conveyor belts. We have a robotic arm. We have a sweeper here. We have a reservoir, and we have a burning or heating chamber. Okay, so let's get started. The code is written into two parts due to a few issues, so we'll run the first part for you and then the second. Okay, so to begin with, we have a robotic arm turning around onto the conveyor belt. And then this solenoid is going to be activated. Once it's activated, it's going to turn into a magnet and then magnetize any magnetic material that's on the belt. So as you can see, this blade is being lifted by the arm. And then the robotic arm is going to rotate on its axis and then drop the magnetic material into this container. So let's wait for it to get deactivated. I guess, okay. So there it goes into the container. So once that is done, we won't want to waste a lot of time. So once that is done, we are going to move on to the segment where we separate the plastics from the non-magnetic metals. Yeah. So run the next one. Okay, so we're going to go ahead with the second part of the program. Okay, so with the second part of the program, the conveyor belt is supposed to be propelled in order to drop the plastics into this pool of water. So first of all, the water is being pumped from the reservoir into this bowl. So once these materials get here, the plastics, due to their low density, are going to float on the surface of the water. Okay, so if you realize, if it gets here, it floats on the surface of the water, and then the non-ferrous ones, the heavier or the more dense ones, are going to end up at the base of our water chamber. Okay, so once this happens, this sweeper is going to be programmed to move forward. So once it moves forward, it sweeps over the surface of the water, getting the plastics out. However, we are unable to connect this motor due to the fact that we don't actually have every single thing we need to make this whole experiment work. So we just want to give you an illustration or portray the idea, because that's the most important thing of the project, solving the solution. Okay, so the plastics are going to be swept off the surface of the water onto this conveyor belt. Once again, we don't really have a motor to connect the belt as well, but I hope you get the idea. So once the plastics get onto the conveyor belt is going to be propelled, and then the plastics are going to be dropped into this chamber. So once the plastics get into the chamber, the heating system is going to be activated with the help of a relay. So this is equally automated. So I made mention of a relay because it helps us automate stuff. It helps you tell a component when to turn on, when to turn off. Okay, so once that is activated, we are going to have to wait for the heat chamber to heat up the plastics and then melt them into a molten state, so that it's going to be easier for it to take up the shape of whatever we're trying to mold. Okay, so you could use this to form bowls, you could use it to form spoons, use it to form forks, and once we have magnetic materials or materials collected here, we could also melt these as well and then use them to form probably pots. You could use them to form spoons as well as forks and other metallic items that we'd use in our daily lives. Okay, so I'll transfer the mic over to my colleague to help us conclude this presentation.
The chamber from our research takes about 10 to 15 minutes to completely melt the plastics into a liquefied state before it's going to form a shape of whatever we intend. So if you look inside, we have just a bowl in there with the plastics on it. It's going to melt that bowl, and then it's going to, the liquid, thank you. Yeah, we're done.
Just wanted to find out, the materials in there is supposed to be heated and melted, but the container is made of wood. I'm just trying to find out how...
No, this is it's just a prototype we've made. It's actually, we understand that the wood is not the best thing, but we just want to show the idea of a chamber, which should be airtight, of course, but can't really portray that.
Thank you.
Thank you very much. Great job, guys. So my first question is, how is this unique from existing processes that are out there for waste segregation? And then my second question is around the plastics part. So you mentioned that you take out the ferrous materials and you leave the plastics, but are you accounting for different types of plastics? You know, PET is lighter than HDPE, they float maybe, but are you melting all of them together, or will there be another process to, you know, differentiate between the different types of plastics?
Okay, thank you very much. Okay, so what we are melting here is purposely HDP. They are only HDP bottle covers. Yeah.
But I mean, in an ideal system, in an ideal...
So in an ideal system, what would it look like? Or will it always be handling just HTP?
For now, it's HDP we are working with, so probably in our upgraded versions, we'll consider looking into that.
Okay. So thank you very much. Give them a round of applause. And we shall move on to the next school. That's Ghana National College. Move on to the next school, Ghana National College. Please, let's make our way to the next stand.
Ghana National College.
Good afternoon. I'm Haniet Ishmael.
Lawrence Kwabila.
And I'm Anastasia Neti.
We are representatives of Ghana National College. Last year, a 17-year-old girl from our school lost her life. 3 months after that, a member of our very own energy club almost lost her life when she had a severe asthma attack during prep. The workers were burning plastic waste at that time, and then literally all asthmatic patients were fainting left and right. We knew that both these incidents occurred because of the excessive burning of plastic waste in our school. So as young innovators, we knew we had a challenge at hand and we needed to solve it. To do this, we conducted a series of research and found out that 1.1 million tons of plastic waste are produced in Ghana every year. Only an alarming 5% of these plastic waste are recycled. So then we ask the question, what happens to the 95%? Well, some of these are sent to landfills. Others are gathered in the ocean. These plastics are burnt to release harmful gases into the atmosphere, depleting our ozone layer and causing respiratory diseases, leading to innocent people like our classmates losing their lives. To lessen or even better eliminate the pollution of plastic waste in this country, we as the Energy Club members of Ghana National College initiated Sanitation Our Life, which aims at attaining Sustainable Development Goals 12 and 13, which are ensuring sustainable consumption and production and climate action respectively. So, Lawrence.
So to give plastic waste a new sense of value, we decided to use the plastic waste we gathered on school campus to manufacture products like mosquito trapping torchlight. and a power bank, and a pencil case with an embedded power bank, and then a normal torchlight. So we use knowledge we acquired in class and applied it in this sector. So I'm going to take you through the series and the procedures which we used in making this power bank. So first of all, we connected our batteries in series with the USB component or the circuit board of a charger adapter. And how we did this was, if you look at the charger adapter, it has AC terminals. But since AC requires 240 volts for it to work, the battery cannot be used here. So we bypass the AC terminal and the transformer over here and use a multimeter to determine which of the USB components are working in the terminals and connected the battery in series to them. Then we took wires and connected them to the AC terminal, which can be used for recharging the battery. And we connected them to charger pins where the AC source, where the AC current will pass through. And we placed it inside this case. And you can see that we perforated holes for the USB and also for the charger pins where the AC will pass through. So we are going to demonstrate how this works. So as you can see, it's charging. So the reason behind this power bank is that some of our mothers, those in the market, and other people who can't afford power banks, especially some of them that use this type of phones, they need this type of power bank because this one is easily affordable. Because most sold on the market are very expensive due to their components that are in it. But as for this one, we gathered them from sport gadgets and determined which component is faulty in this circuit and replaced them and used it for this power bank. So Anastasia will take you through the power bank pencil case.
So with the pencil case power bank, we cut the bottles gathered from campus into 2 pieces, sewed them together with a zip, embedded the bottle top power bank into it, and painted it into our finished product. So with this pencil case, it can be used in all aspects of life. It can be used by teachers, office workers, lecturers, seamstresses in keeping their markers, car keys, office pins, and any other little things. It can also be used by students in keeping their pencils, rulers, sharpeners, erasers. And with this pencil case, it serves as a source of light for students to study during periods of power outages. So we made this pencil case from the waste we gathered from campus and other parts of the community surrounding our campus. So we can sell this pencil case for 5 cedis. Won't it be nice for you to buy a pencil case with a power bank at 5 cedis? How will you feel to buy a pencil case at 5 cedis with an embedded power bank inside? Whilst we know other power banks, other pencil cases sold in the market without anything, just raw material, cloth. They use clothing sewing it. So when you buy that one for at least 5 cedis, and you buy this for 5 cedis, how will you feel? So our sister here will take us through how the torchlight was made.
So with the torchlight, using our innovation, the vitamin C container, we connected with the battery in series with a circuit board, and then also in series with an LED and the switch. And the switch. And then during the conference meeting, the Zoom meeting we had the last time, the judges advised us and told us that asked us if we could improve our touchlight. So we did. We added an innovative feature, that is, our touchlights can be turned on with moist fingers, if you don't want to use the switch. It can be turned on. And then it has a mosquito trapping feature. That is, if whilst you are using our touchlights to learn or anything, you are also protecting yourself against malaria. Wait. What are you ending?
So instead of using insecticides and quells, which can harm asthmatic patients, you can use the mosquito trapping bulb, which does not produce any scent. And with the mosquito trapping bulb, all the things we used in making them were recycled. So anyone who buys it helps in attaining the SDG goals 12 and 13 by 2030. And the things used in making these touchlights cost 17 cedis. So when sold in the market for 20 cedis, you can derive a profit of 3 cedis. Yeah, it's relatively cheaper as compared to those sold in the market, even with the mosquito trapping feature.
These torchlights, when produced in large quantity, can produce jobs for the Ghanaian youth and also can be exported outside and be used worldwide.
And with our touchlights, power bank, pencil case with power bank, it can last for 4 to 5 years. Yeah, so when you compare these touchlights to those sold in the market, you see that when you buy them, 3 months later, then they are spots. But because we did it ourselves and we know the things we used in making them, so it can last for about 3 to 4 years. Yeah.
With our initiative, Sanitation Our Life, we are very confident that we will contribute greatly to attaining the Sustainable Development Goals by 2030. Thank you very much.
So we'll take some questions from our judges. Any questions from our judges?
So I'm particularly curious about this mosquito trapping bulb. Please, can you tell us how it works?
Okay, so there is a special capacitor in it that produces a scent that attracts mosquitoes. So when the charges are stored in it, it heats up, and this causes it to produce some kind of scent that attracts mosquitoes. And then you can see that the cap of the torchlight is specially designed with holes in it. So the mosquitoes will pass through these holes and then enter, then the heat from the electrocuted and then killed in the different. So after, let's say, every 3 weeks, you can open your torchlight and then pour your mosquitoes away. Yes.
Okay. So I would love to see that you can use your plastic to manufacture that trapping. So I think that would even reduce of the bulb in the future.
Thank you very much. Next.
Any last questions before we move on?
Yes.
Blowing your mosquitoes away, are they dead mosquitoes or
no,
live
it
one?
attracts the mosquitoes. Live mosquitoes, sorry. Yeah. So they get into it through this place. Through the hose. So when they get inside, they get electrocuted, then they die.
Okay.
So after they are dead, maybe you bought it by 2 days ago. Every week you can open it and pour your mosquitoes away.
Yeah, because you say you are mosquitoes, that's why I'm asking whether they are dead or alive. Thank you.
They're dead mosquitoes.
All right. Thank you so much, Ghana National College. Please give them a round of applause. And we are going to move on to Okaikoi-man School. We're going to move to Okaikoi-man School. Let's make our way there.
Okay. Okaikoi-man.
My name is Kofi Ojuponajiman. And you?
My name is Dogbe Nicole Ayo. I'm first year.
Please, I am Ode Richmond Kwesi, first year.
So this is a concept of a... Okay. This is a prototype model of a recycling and upcycling plant we are trying to build in the future in our school. Okay. This is a recycling and upcycling concept that we're trying to build in our school. And this part is the disinfection stage, where trash goes in and being disinfected by UV light. Yeah, that's how my voice is like. It's deep. Yes, please. And after that, this is the projection stage, where plastics and metals and the rest have been changed to this one. And this prototype is being powered by urine. You may ask why, like this. You may ask why we are using urine. Urine has an electrolyte inside, which is like the urea. It has an electrolyte inside, which is urea. That we use dead batteries, like we break them, and after we remove the catalyst in the rack. Okay.
Hello, please. I am Ode Richmond Kwesi, a president of Okaikoi-man School. And as we are here, what you have in front of us is a recycling and upcycling plant. What you have in front of us here is a recycling and upcycling plant. With this, we are using the human waste, I mean the urine. We are using the urine to generate electricity to power this house. So as for now, please, I would like for you guys to come in here and see what's here. Please, what you're having here is the wire. This is the negative, this is the positive. And it's being connected to this side. Please, hello. Please, as for this one, we are going to use it to generate electricity to power this house. Please, as you can see, I've turned it on and there's a light appearing at this place, which is we're using to power the house to be able to light the house. Okay. Please, we are also having a concentration game. Please, I would like for you guys to come close to look at it. Please, what you're having here is a waste product, a joint waste product. We've been using waste product from these things. We have the spoiled charger. This one was actually taken from a charger. And we all gathered those things to make this thing. This one is actually meant for kids, to help them to concentrate more. And this one, it is being played by this. You have to start this thing from here. You are not supposed to let it touch it. When it touches, it will make noise. So you just have to start from this place. You go. When it touches, you have to get back and start over again. And you have 3 chances. And with this, you can change it to any mode you like, to even challenge yourself. So when you move it, it will not be able to make sound. But when it touches it, it will make sound. And please, what we are having in front here again, this is actually, I can say it's a stove. This one is used to cook. It's used to fry an egg. And as you can see, I've already done one here, but I can even demonstrate some here again. Let me take something to remove it. Oh, this is this. Okay. It's okay. And please, as for this one, I think it's going to take a bit longer, maybe from 1 to 15 minutes, then to be able to fry it. But because we are, because we are demonstrating it, we have to make it this way just to demonstrate it. What do we? And please, as for the concentration game, we are having a seat. It's actually a chair. You just have to sit. You just have to sit. Then you have to play it. That's how it's being made. Okay. Hello. And please, here we have a first aid box. Hello. At this place, we're having a first aid box, which was used by a waste materials, such as like waste things which will not be used to do anything, and we use it for first aid box. What do you have again? I have to use a mic.
Okay, so this is our recycling plant. It is a prototype of the recycling plant we want to do in Okaikoi-man School. So this is where the waste will enter. It will enter here, then it will be separated, washed, cleaned, so that when it reaches the production site, it won't contain germs in order to contaminate the workers who work there. So this is a kind of like delivery tube. It will deliver the waste from the segregation area or the cleaning area up to the production site so that people can work on it. So these are examples of products which will be produced from our production site. And one wonderful thing is that the production site is powered by urine. So we all know that many human beings think urine is useless because that most Ghanaians, they urinate anywhere, anyhow, anywhere. So because of that, we decided that we will make use of the urine. So we don't need a whole world's urine. We just need, let's say, a gallon of urine in order to power a whole building. So the urine, it contains electrolytes like urea, which will be used to power it. So the urine we make, in order to power the urine, we use old batteries. So the batteries, they are opened up, the cathode is taken out, the anode is also taken out, and we connect them with a wire and use this insulator, such as Charlie water in this case. So we cut the Charlie water into pieces, then we use it. So the aim of this project is to reduce pollution. So we make use of electronic waste. So electronic waste, they kind of leave marks on the ground and they can make lands barren. So we make use of the electronic waste in order to power the house. So it will reduce pollution. It also reduces the way people urinate around. It also makes use of the 3 R's, which is reduce, recycle, and reduce. Reuse, recycle, and reduce. So we made use of the 3 R's in order to build our house. So with this way, we are going to reduce the cost in living. You know, as Ghanaians, we are regularly hearing of doomso. So instead of relying on nuclear power, hydroelectronic power, instead we are going to make use of urine. This will ensure that people go home, they go and urinate in their own houses, instead of urinating on the ground anywhere. Like some Ghanaians, they behave like that. So we are going to reduce the cost in living. And to also ensure that people use their money wisely. So